My name is Amanda Hill. I am an Android developer at thoughtbot. There's the logo. They paid for me to be here, so I have to give them a little shout out. As you probably guessed from the title of the talk, today I'll be talking to you about Expandable RecyclerView. Expandable RecyclerView is an open source library that I wrote for expanding and collapsing groups using using RecyclerView.Adapter. It's a visual library, so there are a lot of visuals here. This is the collapsed state of a list of musical genres. This is the expanded state, and this library will help you achieve this. When you tap on a group, it expands to show you all the items within it, all the children items, and when you tap it again, it collapses. A big question that I get a lot, and one that I think is really important for all open source software and projects to answer, is why? Why did you build it? Why do you think it's important? I mean, you're all here, so you don't really, why should I care, I guess? The short answer to this question is pretty simple. For RecyclerView, the Android SDK does not have a solution. The personal reason is I work for a development agency and we have clients, and clients have needs and wants. And so I didn't really have a choice. Another question that I get a lot about the library, which is kind of a segue into this needy client, is aren't there already a lot of libraries out there? Aren't there a lot of solutions to this problem? I was obviously not the first person to come across it. I think expanding and collapsing lists is an incredibly popular pattern on the web, and I was definitely not the first mobile Android developer to be asked to build it. The answer to this question is even shorter, and it's yes. There definitely are. I think most notably is the Big Nerd Ranch library. It's also notable because it has the exact same name as this library. It's because the name is pretty literal. There's nothing fancy or clever about it. It is literally what it does. And actually, when my client first approached me with this design pattern, I looked to use their library. Unfortunately, for me at the time, there were a few limitations about how extendable it was. That's not to say there's absolutely nothing wrong with the library. I was at the time designing a fashion app, and the client wanted the ability to filter a list of products. And so in that feature set, when you would expand a category of, let's say, shirts or colors, you needed to also select the children. And that was difficult to do with their implementation, so I set forth to build my own. I'm going to talk you through the challenges and how I built it, but I think first to kind of give everyone some context for anyone who hasn't used it, we'll walk through how you would use it. We're going to use this genre app example throughout the talk. This is actually the exact same sample app that's shipped with the library, so all the code that you see here is already up on GitHub and has been for a while. So first up is the modeling. We have two models, the child model, which is an artist. This is an incredibly simple Pojo. You can make it as complicated or not as you want it to be. For this app, it's literally just this. Next up is going to be the group. The group has to extend this expandable group class. Expandable group has a generic parameterized type, so it associates a title, in this case it's the title of the genre, to a list of of any type of items. In our case, it's going to be a list of artists. By forcing any kind of group class that you want to use to extend this class, we can use type safety throughout the library and assume that whatever group, which really is just kind of a wrapper around this concept of something that has a name of itself and a list of items, we can achieve that. So our genre example would look like this. It extends expandable group, and we pass it the type of artist so that it knows in the constructor exactly what type we're using. Next up are the views, or in RecyclerView speak, the view holders. So first up is the child view holder. This is a really kind of standard RecyclerView view holder. Nothing too fancy here. I apologize, it looks like a lot of text, but it was really just to illustrate that this is a standard view holder. And to make it compatible with our library, instead of extending regular RecyclerView view holder, you have to extend child view holder. It's that simple. Next up is the group. Again, super standard RecyclerView view holder. More things going on here because there's a name, an arrow, and an icon, but very simple standard. And again, the only change you have to make here is extending the library-provided group view holder class. Next up is the adapter. The adapter is called Expandable RecyclerView.Adapter. I dare you to try and say it 10 times fast. You can't, and you'll sound very silly. It extends RecyclerView.Adapter. And to take advantage of a lot of the types and the kind of the reason why you have to subclass so many things throughout the library. I know it kind of violates, I think it's issue 16 in Joshua Block's effective Java of inheritance or composition over inheritance. But it does give us some type safety, and that comes into play here. Again, I apologize, this is small to read, but what it says is that it's a RecyclerView.Adapter with two types. The first type is a generic group view holder type, and the second type is a generic child view holder type. So this makes it so when you implement this class, we can fill a lot of the information out for you, and it should hopefully make your lives a lot easier. So if we want to start writing the adapter, first step is the constructor. This immediately takes in a list of items. This is not required in regular RecyclerView adapters, but given that there's a lot of state to maintain, it made everything a lot simpler if you just forced the adapter to be instantiated with the list of items or the list of groups. Next up, there are 4 abstract methods on this adapter. The first one is onCreateGroupViewHolder. You'll notice all the naming here is very similar to regular RecyclerView adapter. That was intentional. It's supposed to be easy to read and easy to use. Also supposed to be self-explanatory, but I'm up here anyway. Next up is onCreateChildViewHolder. You'll notice again, the parameters here are identical to what you would see in the base adapter. Next up is onBindGroup. In this case, you get past that group view holder that you passed as a parameterized type, a flat position, which we'll talk to in a bit, and the actual group that you're binding. And lastly is the onBindChild. Same thing, flat position, holder, the group, and actually the index of the child. So you know, in this case, you do have to kind of iterate over the group to get the child that you want to inflate. But if you wanted to also use the group information, I thought it'd be helpful to pass that through. All right, going back to our genre adapter now. We have a genre adapter, which extends the expandable RecyclerView adapter, our 2 types, genre and artist view holder, and our constructor. So going through those 4 methods, first up we have onCreate. Nothing fancy here, no need to read these, it's just how you inflate the artist view holder. Next up is I skipped one. onCreateGroup, onCreateChild, again, very standard. onBindChild. What I didn't include in the artist view holder was this bind method. I think it's a pretty standard pattern for keeping the bind logic in the view holders and out of the adapter to keep it a little bit cleaner and smaller, but by all means you could absolutely do it here in the adapter as well. And lastly is onBindGroupViewHolder. Same thing, a bind method that was in the view holder. So now all together, so nobody can read it because it's really small, this is the genre adapter. I recognize that, and I don't expect any of you to be reading every single line here. The point is just to illustrate that this is it. It is not, I don't know the exact number of lines, but it's really straightforward and it really is a constructor and 4 methods. Now, to see it on screen, I use an activity and all the sample code, but you could absolutely use a fragment, or I don't know if you can put a RecyclerView in a dialog, but any sort of view context. Standard Android activity. To get this working, we'd have to add our genre adapter, RecyclerView and a reference to it from our layout, create our adapter with a static method getting all the genres, adding a layout manager, and setting the adapter. Now if we run it, it works. Yay. That was it. It's really that simple, but there's something here, if any designers are in the room or detail-oriented people, you'll notice that the arrow is not rotating for the rock group. It's just staying stuck. And that's just a visual clue to the user that can make your app more delightful. But as it stands right now, it's sad. So if we go back to our genre view holder, this is exactly as it was before. There are 2 methods that come with group view holder that we can choose to override. You don't have to, but if you care to update the group in any way on expansion or collapsing, this is where you would do it. Again, the source code for this is all online, so you can see actually how the animation is being achieved, but it's just rotating that drawable. And so if we run it again, now it's rotating and is a lot more beautiful. This is Happy Cat. All right, so now how does this whole thing work? This library is obviously based off of RecyclerView adapter. So to understand how this library works, you need to understand RecyclerView adapters. They describe themselves, and according to the documentation, RecyclerView adapters provide a binding from app-specific datasets to views that are displayed within a RecyclerView. In English, all that means is that the adapter is a middleman. It's a translator finding harmony between data and views. which raises the question, how does this harmony happen? A quick kind of refresher into RecyclerView a little bit to see how this translation from our backing data set to the views happens. RecyclerView.Adapter is an abstract class. It has 3 methods, which any subclass has to use. The few things to note before we go through each method is that there is no backing data set here. The adapter class does not require it. That's because it's just a translator. I cannot say that enough. It doesn't know about your data. It doesn't care about your data. It's pretty common in subclasses to include it as a member variable, but it is absolutely by no means required. So first up is onCreateViewHolder, onBinds, and getItemCount. So now let's look at these methods and in what order they're executed, because order really does matter here. First up, we have getItemCount. This call has 2 purposes. The first is to determine and to let the RecyclerView know, is there any data in the first place? I'm not going to waste time inflating something if you're not going to bind it and there's nothing there. The second is that this number is used to tell the RecyclerView exactly how many views to create. The next method is called getItemViewType, and this position integer that it passes you is actually a number between 0 and n, where n is getItemCount. So no matter what your data set is, it's kind of important to notice here, and you'll start noticing in a lot of the callbacks that the RecyclerView.Adapter has, that it's iterating over your data set linearly. Only single-dimensional data. The RecyclerView can only accept single-dimensional data, because again, it's a number, this position is from 0 to n, where n is getItemCount. Next up is onCreateViewHolder, and this is where that using the getItemCount, which then uses getItemViewType, is passed through so you can create the right view type. So if we kind of go back to our app as an example, we can start to look at a little bit how these methods are executed. This is all of the genres collapsed. On the left, we have our data, just 5 genres, and on the right, you can see them all collapsed. Notice here how the view indexes and our data indexes match up perfectly. That's a very pleasant visual experience. But what happens when we start adding a second dimension to our data set, and we start adding artists to the genre? Now these indexes don't match up. Where previously 1 was jazz, as you can see on the right, now 1 is actually a type of artist, and it's queen. This data is kind of pseudo-array JSON, but just to illustrate the differences between now our data set and the views. If we wanted to make our view match this data, we'd have to expand the group. Unfortunately, if we did this for every item, there would be no point in this library because it would just be an expanded group with a bunch of header sections. This is no fun. On the bright side, we've now identified the problem that this library has to solve. Also kind of going back to the why, this is why, or rather, this is why, and this is our problem. We have a 2-dimensional data set, and the RecyclerView only works with single-dimensional data. Another way of thinking about this, because I realize that can be a little kind of confusing, instead of single-dimensional data, is to think of them as flat list positions. But before we kind of get to this, solutions for this problem. I think I only came up with 2 possible solutions. One is to have our adapter actually have 2 data sets. One of our backing data set, which is 2-dimensional, and some converted version that was semi-flat, so it would be what you saw on screen. So you'd have your full list of genres and all their artists, and then you'd have whatever was expanded on screen. For what it's worth, this is exactly how Big Nerd Ranch does it, and is a very valid solution. I, however, found that maintaining 2 data sets became complicated, and it was hard to follow, and when it comes time to extending, it's a lot of things to maintain. So the other alternative is to have just your 1 backing list, but have some object that's translating them, some way from going from your full list to what you want to see on screen. Because again, decoupling, we shouldn't need to keep our models and our views so tightly coupled. So as I said before, the single-dimensional data could be thought of as flat list positions. A flat list position is just a view index. It's another fancy way of saying it is the position of an item relative to all the other visible items on screen, but it's just view index. The reason I'm using a lot of this verbiage, I realize in talking it might seem more complicated, but a lot of it was inspired by actually the Android SDK. For ListView, there's an ExpandableListView class. So if you have no interest in RecyclerView, you don't need any of this. You can just use ExpandableListView. And a lot of these namings were pulled from them. So to kind of test everybody's knowledge, I have a few examples to test if we can all guess the flat list positions. Again, view indexes, or indices. So first up is rock. Any guess what the view index of rock is, or flat list position? If you guessed 0, you were right. And one more, just to make sure you really get it, is classic. Any guesses? No, it's 6, yes. Awesome, great. So now we understand, we have kind of some language and some context for how we can solve this problem, but how are we actually translating it? We know we want to go from 2 dimensions to 1 dimension. Say hello to my friend Expandable List. Expandable List is a translator between the flat list position and our backing data set. It's exactly what I just promised you it would be. All right, the Expandable List is a pretty decent sized class which has a lot of helper methods for translating, but it really all funnels down to this one method. Again, you don't need to read absolutely every line here. The important thing is really just the method signature. It's called getUnFlattenedPosition because we're trying to take the reverse of a flattened position and get the actual truth of this item in our full 2-dimensional set. The object it's returning is called ExpandableListPosition. This class, let's say hello to it, is a direct copy and paste from the Android SDK. It just has package local scope, so I couldn't use it, but I did nothing to it. I didn't touch it at all. ExpandableListPosition is an object that can refers to an item in an expanding list. It can refer to either the child or the group. It has 4 methods on it. The first step is type, which is an integer, just like view types if you're used to working with RecyclerViews. It has 2 static types, or 2 static integers, excuse me, one for parent, or one for group, and one for child. Next up is group position. This refers to the index of the group in the list of groups. Thirdly is child position, and this is the index of a child within its group. And then for fun, they have flat list position. I have never needed this, but to kind of keep things simple and not confuse people, like I said, it was a direct copy and paste. This class is really very helpful, and Google was pretty clever to build it in the first place, because it saves you from having to iterate over your data set a bunch of times just to get all this information. If we go back to this method, we can just iterate over once to determine if it's a child or a group, and then in the case of a child, we can include information about that group. We can say what the group index is, we can say where the child lives within that group, and so it's kind of a once and done. Also, the advantage of keeping this in one method is that it's super testable, because you're only ever converting from one place, and so this method is incredibly well tested, and you can assume going forward that any translation works if this works. Sorry. All right, so now if we go back to our adapter, let's start plugging these pieces in, or rather, this is the source code adapter. So first up is getItemViewType. In this class, the ExpandableRecyclerView.Adapter has an instance of Expandable List. I don't use Hungarian notation, but trust me, that's a member variable. And you can see here, we're calling through to get unflattened position, and we're passing that flat position that we looked at earlier as being part of RecyclerView.Adapter. And lastly, we just call type, which returns 1 or 2, representing a child or a group. Next up is onCreate. This looks like a pretty standard onCreate method if you had multiple view types, which we do, a child and a group. We switch over to each type and then pass through to abstract methods that allow any subclass to create their group or create their child. Next up is onBind. This is where it kind of gets a little bit more fun and we get to start using these objects that we've just covered. So first things first, we're going to create an expandable, or rather get the expandable list position from the position being passed to us. Next up, just for clarity and to make the code clean, we're going to call the group, because in both cases we pass along the group information. Then we switch over the types, and again, pass through to these 2 abstract methods that subclasses can implement, onBindGroup and onBindChild. So now you kind of see where the data is coming from, where the translation is happening from those earlier methods that we implemented. Yay! Now we've kind of figured out, we've got a complete collapsing and expanding list. Awesome. But we have this in the beginning for either via ListView or Big Nerd Ranch. As I promised you in the beginning, if you or my client wanted more, this library comes with 2 extensions. And we're going to walk through what they are and how to build them to kind of show off a little bit how easy it is to extend, and then hopefully to inspire you all to go home and build your own extension and fork it. And that was kind of my hope in doing this, was that with a little bit of background, anybody could extend this. So first up is MultiType Expandable RecyclerView.Adapter. Now I say that one 10 times fast. This version of the adapter allows subclasses to implement different view types for both children and groups. What that looks like in the wild, and this is kind of a boring example, is in this case we have different view types for children. We have a different view type for our favorite artists and for regular artists. Let's build it. This was our child class from earlier. First up, we just have to add the concept of something being a favorite. Nothing crazy, boring Java. Next up, we need to actually have a different view holder type for our favorite child view holder. If we're going to add more view types, we need more views. Now we're going to go from our genre adapter to our multi-type genre adapter. First up, the constructor, or rather the class signature, is very similar. Again, we need to have our parameterized types, except in this case, we know the group view holder is always going to be genre, but because we have multiple children view types, the most accurate information we can give the system is that it's just a child view holder. Next up, we're going to add view types. If any of you were just at Lisa Ray's talk, she advised against this, so yeah. This is still using this method, but it is important to note here the 3 and 4. Because expandable list position has 2 integers, and those integers are 1 and 2, you can, like the compiler will allow you to do 1 and 2, but you will be very unhappy and it won't look like you expect. So there was no more type-safe way for me to kind of intentionally guarantee that you were starting not at 2, but please keep in mind in your extensions that these have to be 3 and 4. So first up is getChildViewType. This is a method that the multi-type adapter provides. There's 2 methods, one getChildViewType and one, which we'll do next, which is isChild. But for this one, you get both the group and the child index because we know it's a child. And you just have to look into your data and based on whatever assumption in this case is favorite, return the correct view type. Next up is isChild. In this case, you could have an infinite number of view types here. You just have to have some way to tell the system whether a particular view type is a child or not. And so again, altogether, this is what you need. This is the only difference between our regular genre adapter and our multi-type genre adapter. Have I lost anyone? Now we're going to kind of dig in a little bit to how it's made. As you might have guessed, it's made using view types. There are 4 methods: getChildViewType, getGroupViewType, isGroup, and isChild. And the reason why I have 4 methods as opposed to just 2, which, for example, like, why couldn't we just have getChild? And that's because of the order of methods that we covered earlier. First up, the compiler is going to ask for the number of items. And next up, it's going to say getItemViewType based on position. Okay, great. But then in onCreate, we need to know, is that view type a child or not a child? And so we don't know this information at that time. So we added simple Boolean methods to confirm whether a view type was a child or a group. Sorry, that slide was not supposed to be there. Oh, sorry. It was. This is our expandable RecyclerView adapter. And this was our getItemViewType method. To update it to be our multi-type expandable adapter, we simply go from 1 line to a lot more lines. But we're just iterating over exact same thing as the onBind from before, actually. And in the case where it is a group or a child, we then pass it along to subclasses to allow them to say, okay, we know you're a group, but what type of group are you? Or we know you're a child, but what type of child are you? Again, not as important to read every line here, just to kind of see the gist of how we're switching and passing these methods along. And that's really it for the multi-type. It's the addition of those 4 methods and this update for getting the view type. And if you were also like my client and you wanted even more, there's the expandable check RecyclerView library. This is another extension. This one allows for checking of multiple or single children. Looks just like this. In the case of that fashion app, it was really helpful because you could select what filters you wanted. All right. Again, starting from the beginning, here was our good friend, the genre class, which was our expandable group. In this case, we're actually making some changes to the models, not just the views, because being checked while it is a view state also affects the data. So rather than extend expandable group, you need to extend single check expandable group. You may be wondering, what if I wanted multi-check? So we look a little bit deeper into checked expandable group, which is the subclass of all the different checking types. You'll notice that there is a method called onChildClick, and in the single check example, we make sure to check the one that you've just selected and then uncheck all the rest, because that's what single check means. And in multiple, I think the method is empty because we're not really doing anything. We're just allowing any listeners that want to kind of hone in on this event to pay attention. All right, so back to our example. This is our same old child view holder from before. That's why it's all in white. To make it work with our checkable library, instead of child view holder, it needs to extend checkable child view holder. Checkable child view holder is a subclass of child view holder, but it needs to know about the view that is being checked. So it needs to know about a particular view that implements checkable. So there's a method that you have to override here, which is called getCheckable. And to update our adapter to work with it, instead of a regular text view, we'll make it a check text view, but you could have a button or any view you want that implements checkable here, and just make sure that you pass it in the getCheckable method. Yeah, and according to Porgy the Pig, that's all, folks.